Hollow Knight swooped in a few years ago and quickly took its place among the top-selling Metroidvanias of all time. It's become a must-play for fans of the genre, sitting among other great titles like Symphony of the Night and Metroid Prime. But unlike those other games, Hollow Knight was made by a small indie team. Despite their limitations, it was still a massive success. It was so successful, in fact, that it's become one of the poster child games for the Unity engine, alongside other titles like Cuphead, Hearthstone, Rust, Ori, and many more. As a game dev who's made a handful of Unity games myself, I'd say I'm pretty familiar with how the engine is structured behind the scenes. So lately I've been having fun breaking apart these big Unity games. Partially to just put in some dumb jokes and mess around with the code, but mainly to peel back the curtain and reveal some interesting tricks that the developers pulled off. I recently did some similar videos on both Iron Lung and Cuphead. I was able to find some pretty interesting things in those that you'd never expect just from playing the games. So after I got a lot of comments asking me to take a look at Hollow Knight, I figured, why not? Like I said before, I think it's an excellent Metroidvania. Although, Symphony of the Night still holds my personal top spot. But I'm not spending weeks investigating, decompiling, and rebuilding an old PS1 game, so Hollow Knight seemed like a great choice in comparison. I guess we'll just have to settle for bringing a little bit of Castlevania into Hollow Knight. I mean, there are a lot of pretty obvious parallels here. Like these scenes, which lined up perfectly, so I just had to pull the Castlevania background into the game. Makes you wonder what Hollow Knight would have looked like if they went with pixel art instead. There's a lot of places throughout the game where I could drop some Castlevania backgrounds and it wouldn't feel too out of place. I thought that Quirrell was a bit lonely on this bench all by himself, but a couple more steps and it turns out he's just watching Alucard do his thing. Yeah buddy, I wish I could turn into a blob of mist at will too. Wait a second, I have access to the code, so I can just write a little script, have it fail about 20 times, finally get it running, inject it into the game, and now the knight has magic mist powers. That probably would have come in handy earlier, huh? But anyways, this is just a little taste of the basically limitless possibilities we have when hacking Unity games. Sure, it was a dumb idea to implement a Castlevania mechanic and spend all that time just for 5 seconds of footage, but it was probably all worth it, right? Right? Anyways, people are always asking to see what games look like out of bounds, which I can agree is pretty interesting most of the time. It's not that hard to do, but in a massive game like this, there's just so much to find out of bounds. I got a good amount of footage, but with 500 unique scenes in the game, there's always going to be more secrets to discover. That said, I'll be digging deeper into the technical side of the game later in the video, but for now, let's check out what's hidden just outside of view in Hollow Knight. Zooming out in the first area of the game looks pretty much as expected. Although one big issue here is the heavy vignette filter around the knight, making it hard to see anything in the distance. We want to zoom out and see the whole map at once, but the filter is preventing that. So after a little more digging, I eventually found the source of this vignette. It's actually just a simple object attached to the player that darkens everything far away. Disabling that object instantly brightens up the world, allowing us to see entire scenes at once. When you get a good look at them zoomed out like this, you can really appreciate the complexity of each scene. Like this room, with the hanging platforms. When we zoom in, you can actually see how every unique object is layered on different distances from the camera. Even well into the background, objects are placed on different layers to simulate realistic depth. Almost every scene in the game is made up of countless highly detailed layers just like this. Even if they reuse some graphics here and there, there's still a massive number of hand-drawn objects throughout the game. But admiring the art aside, there are some interesting things to find out of bounds, like the UI just sitting off in the corner over there. My best guess for why they did this is that there's a second camera only rendering those UI objects onto the main screen. It's interesting because Unity supports screen overlay UI, so the second camera method is mostly outdated. But hey, it works, and players are none the wiser, so there's nothing really wrong with it. Speaking of off-screen objects, you might notice some particles over in the corner of the screen. Those are actually projectiles and some other effects that are preloaded when the scene starts. Just like in my Cuphead video, instead of needing to load in objects while you're fighting, they just load in when you load into the map. The enemy projectiles just sit off in the corner of the screen until they're needed, and then they get warped into place in sync with their attack animations. It's a small optimization, but loading is often a major cause of stuttering in games, so it makes sense why they'd try to preload as much as possible. While we're talking about optimization, another common technique in games is to disable AI that's off-screen. Hollow Knight does this too, stopping animations, movement, and other logic for enemies that are too far away from the player. Then when they get too close to the edge of the screen, they're re-enabled. Even pieces of the scenery follow similar optimization techniques. Here we can see that moving around causes some distant parts of the level to disappear. If they aren't needed on screen, they can often be hidden to help save a few extra frames per second. This technique is commonly known as culling, and it comes in a few different flavors. One common type is frustum culling, as seen in this popular video from Horizon Zero Dawn. Frustum culling basically means that objects that are outside of the camera's frame are hidden. This is in contrast to occlusion culling, where things can be hidden if they're blocked behind other objects. For example, there's no need to render a static chair on the other side of a wall, even if the camera is directly facing it. So occlusion culling would be the method hiding that chair to help lighten the load on the computer. In Hollow Knight's case, frustum culling is mostly what you're witnessing here. But as you can see, only some small objects actually get culled in the game. Side note, this actually makes the game a lot harder to play when I'm fully zoomed out like this. When I'm far away from the player, the game can incorrectly hide some platforms, making platforming segments come down to pure memory. Anyways, that's enough about the out-of-bounds logic, but there are certainly a lot more secrets hidden within the game itself. Like I said before, the game has 500 scenes, plus a handful of video cinematics, like the stag riding animation. That doesn't actually happen in the game, it's just a video playing while the game loads. You can see here a list of non-gameplay scenes I pulled directly from the code. Mostly obvious things like intro and ending cinematics, but a few surprises like the end of the beta still existing in the full game. There's also a nifty cheat console that you can only access in developer builds, but with a little bit of code injection, I've re-enabled that ability. It's a little hard to see because of how small it is, but it includes a bunch of nice little features to skip major segments, unlock things, and overall make it easier to quickly test parts of the game. It can be a little obtuse to use, like the money generator doesn't appear to do anything when you press it. But it actually just doesn't update the UI, so you won't notice your newfound cash until you move on to the next screen. Another interesting thing we can do is remove door blockers for locked buildings early in the game. Here I opened up Bretta's house after starting off a fresh game. I can grab the fragment inside, but everything goes wrong when I try to leave. The game wants to place the knight outside of the house, but the door is blocked off and inaccessible. It doesn't know what to do, so I just end up stuck, floating out of bounds with the controls disabled. The only thing I can do here is Alt F4 to load back into a normal state. This happens anytime you try to leave a locked area, which obviously shouldn't be possible if you were playing normally. It's just one of those things they didn't have any reason to check for in the code. Speaking of code, I think now's a great time to dive into the actual code. Being such a massive game, there's a ton to sift through, but there's a few interesting tricks here and there. And just like my past videos, I'm going to keep this as straightforward as possible. You don't have to be a game dev or even a programmer to understand what I'm explaining. But if you really hate the thought of code, feel free to skip on to the next section. Otherwise, let's crack open DN Spy and see what really makes Hollow Knight tick. The first odd thing I noticed is that there are two unique versions of the game, regular and Chinese. And I'm not talking about different languages. Hollow Knight already supports a handful of different languages in the code. Searching through the project, there aren't any clear distinctions in how the Chinese build is different, which leads me to believe most of the changes in that version are related to the assets in the game. Swapping out art, audio, scenes, etc. would have no impact on the code, so it wouldn't come up in my searches. I've heard the old rumor of things like skeletal figures being banned in Chinese media. At least, that was the case with World of Warcraft's Chinese version. But I have no access to Chinese Hollow Knight builds, so your guess is as good as mine. Another thing I found while digging through the code is why I always got stuck after leaving a locked area. There's this bit of code here that runs only when the knight is in the right position. This is often used after transitioning between scenes. The game tries to place the knight back in front of the door to the building that they came out of. But if it's locked, that door is obviously blocked off. This prevents the knight from being moved into the proper position, basically soft locking the game. Looking through the game's map data, I found the official list of all zones in the game. Now, I'm not a super big lore person, so it's not like I could explain every last one of these names to you. I mean, obviously many of them are shown directly on the map, but a handful are more vague. All the Hollow Knight lore masters out there can do with this information what you will. One interesting trick the developers do with the code is having two different types of update functions. Update is basically code that executes every single frame of the game. That code would run 60 times per second at 60 FPS, 30 times at 30 FPS, etc. Interestingly, the developers also added their own update 10 function, which only gets called every 10 frames. So 6 times per second at 60 FPS, 3 at 30 FPS, you get the idea. Things that need to be checked regularly, but maybe not every frame, are in their Update 10 function. Checking if the player is out of bounds and resetting them happens in Update 10. So if you go out of bounds, you potentially have a few fractions of a second to do something before the game notices. Could even be useful for speedrunners, knowing that some things only happen a few times per second instead of every frame. Also of note here is that the game is constantly trying to reset the player's X scale and Z position in every Update 10 call. X scale determines how wide the player is, and Z position is how far away from the camera they are. I don't know what actions in the game would cause these values to change, but they had to have a reason to include this. This is a classic example of the bug fixing process in game dev. Can't figure out what's screwing with your values? Just reset them every 10 frames and you don't have to worry about it. But don't hate on the developers for doing this. This is actually way more common in games than you might expect. If the bug is gone and the player is none the wiser, it might just not be worth spending any more development time on it. Speaking of Z positions, I found this interesting bit of code for setting the Z position of just about any object in the game. Like I said, Z position is how far away from the camera something is. This is very important in 2D games because objects will be in front of or behind other objects based on their Z position. For example, imagine you have just the player and a background image. If the player has a Z position of 0 and the background has a Z position of 1, the player will be hidden behind the background. You'd have to swap their numbers to get them to display correctly. On the other hand, if two objects have precisely the same Z position, you get what's called Z fighting. This is when two overlapping things constantly flicker over each other. The game doesn't know which to render on top, so it constantly alternates between the two. It's common in both 2D and 3D games. You've probably seen this plenty of times before, but now you know what causes it. So the devs wrote this little bit of code to avoid Z fighting. When an object is created, it randomly shifts the Z position by a minuscule amount. So the devs can do something like place all enemies at Z position 1 or whatever, and you'll never actually see them flickering over each other in the game. That aside, there's some other small tricks to be found in the code. One example is the Save Data Upgrade handler, which allows players with old versions of the game to use their data in newer versions. This runs silently in the background so players never notice, but we can see in the code specifically what they changed. Certain maps like deepnest_26b were changed significantly enough that their save data needed to be rewritten. I don't know the extent of these changes, but it's nice that they allowed users to keep playing from old saves. Some developers just throw up their hands, opting to wipe old saves or saying they won't be compatible anymore. But anyways, that's enough looking into the code for now. I actually kept my last video pretty light on the tech talk, but surprisingly received a bunch of comments asking me to go more in depth. Hope I was able to satisfy those people while still keeping things understandable for everyone else. Digging into the code is pretty fun and all, but I do it for practical reasons too. It makes it much easier to find where to inject my own code, working in harmony with what the developers have already done. Letting me do things like jump off into space, only to be reset by that pesky Update 10 code. Or manipulating Mila's audio source, letting us listen to different variations of their tune. I can even put some more punch in the dash, letting me zip across the map in an instant. And of course I can change the stag in just about any way I want. From tiny bug stag to ceiling stag, and yes, even wide stag makes an appearance. But of all the dumb little things I ended up changing, adding in that Castlevania mist form from earlier took the longest. First, I had to create a new object attached to the player to hold the mist. Then I had to load the mist from my hard drive into that new object in a disabled state. After that, I had to write a new script that waits for a certain key press to hide the player and show the mist instead. In addition, to give it some mist-like properties, I removed gravity from the player while in mist form. Once you press the key, all that stuff happens behind the scenes and the player turns into a cloud of mist. Pressing the key again swaps you back. I didn't spend any time on making it actually look good, so it appears deceptively simple overall. But that's just a little glimpse into the world of game dev. Things get much more complicated when you have to integrate all that code with some nice animations, sounds, and the like. Given how massive Hollow Knight is on both the code and art fronts, we can only imagine how much effort the devs put into this game. Like I said before, it's no surprise that Hollow Knight is such a massive success. If you like Metroidvanias and have never played it, I definitely recommend giving it a shot. Or if you have played Hollow Knight and not some of its older inspirations, I'll have to recommend Castlevania Symphony of the Night once again. Anyways, that about wraps up my deep dive into Hollow Knight. If you liked the video, subscribing is always greatly appreciated. These videos take a long time to make, so I tend to post smaller updates over on my Twitter. If you want more regular game dev content, that's probably where I'm most active. But as long as there's interest for more videos like these, I'd be happy to keep the series going. If there's any other Unity games you'd like me to break apart, let me know in the comments. Or if you have any questions about the inner workings of Hollow Knight, maybe I can take a crack at answering them. As I mentioned, I'm no lore expert, but I do know a good bit about how the game works behind the scenes. And with that, I'm off to start researching my next big project. Thanks for tuning in, everyone, and I hope to see you all in the next one.